Okay, I hope you can see the screen now. San Francisco tech companies. So now we have these, this is what is given in the question. Let us proceed with the k-means clustering. The first thing that we need to do is center one, what Amita was asking. So let me just randomly take, because we need two clusters, I'm having two centers. All right. So let me randomly pick anything. It doesn't matter because it's an iterative process. Eventually, you will come to one particular answer. You will get one answer. So I will randomly pick company 3. I'll take this value, Control C, Control V. I'll take that as my first cluster, and I also take say company 6, Control C, Control V. This is my first second center. Okay. Now I will calculate distance for each of these companies from my center. Okay. So let us try doing that. This is center 1, center 2. And let me try to calculate the distance. So for the first company, it is going to be this minus this. Okay. Bracket. This minus this plus this value minus this value. Yeah, okay, fine. All right. So somebody was asking something when I was entering this. Yes. Yeah. I don't know who it was, but I wasn't noticing. Was it Amitabh who said something absolute something? Is this correct? What do you think? Is this okay to find the distance between the mean point and that particular value?
I was telling sir to find the absolute, apply the absolute function because it can have negative values. So
exactly, absolutely, yes, you're absolutely right. So because this value, because the center point could be on the left, right, top, bottom, anywhere. So we are more interested in the absolute value. It could be positive or negative. We are only interested in the distance. So not particularly about the direction. So we are therefore using the absolute function ABS. Okay, oh God. Okay, let me do that again. Absolute value. So absolute value of this minus this. Okay, plus absolute value, because we are not caring whether it's a positive deviation or a negative deviation. We are interested only in the distance, plus absolute value of this minus this. Okay, and plus absolute value of this value minus this value. There you go. So this gives me the distance between the first arbitrary center that we have and the company 1. Now I can drag this down, formula down, and I can find the distance between each of these companies and the center point. But you would notice that because I have not used cell referencing, I have not locked the cells at the bottom. My formula is not right for this instance. So let's fix that by locking the cells B12, that is F4, C12, F4, D12, F4, E12, F4. I've locked my cells, but I want the bottom first values to vary when I drag down. So now I have a corrected thing. And as a check, you see this is 0. Why? Because the centroid point is company 3. This is the company. So this value, of course, will be 0. That I have arbitrarily taken as a center. And you can verify, yes, company 4 minus centroid point. So this is the mean distances from the arbitrary center point and each of the companies, each of the data points. Similarly, we do this for data point 2. For data point 2, our distance would be absolute value, this number minus this number here. Let me lock the cell right away. F4, close the bracket, plus absolute value, this value minus 2.7. I'm locking the cell. F4, close the bracket, plus absolute value, take first value minus second value. I want to lock that cell, close the bracket, and finally absolute value, this number minus this number, lock it. Okay, I drag it down, I get the distance, and predictably the last value will be 0 because that is again the number we have. Okay, now all of you clear with this? If you have understood this, please give me a thumbs up. Nobody's understood? Okay,
Sir, what is the seed value here, sir?
No, I have arbitrarily taken 2 random points as my centroid, and I have tried to find the distance from each of my points to that centroid. Correct? What is
Sir,
the
but in the algorithm, sir, there was a mention of a seed value, sir. So this random value which you took as center 1 and center 2 as seed values, right?
That is seed value, yes. I'm randomly taking some data point as my center value. I'm assuming that is the center.
Okay.
Okay. Fine. So for all of you understood, basically I've randomly taken one number and I've looked at the distance between each of these points and that. So this is my first iteration. Now based on this, I would now have 2 clusters. Okay, I am going to have 2 clusters. Okay, now I need to see, because my requirement is 2 clusters. Let me see which cluster the first one belongs to. How do you determine which one the first company belongs to which cluster? What is the rule we use?
Is there a rule or we define a rule for this scenario?
Yeah, whatever. What is your intuitive thing? How do we define the rule? How do you determine
the shorter distance?
Anything which is above 5 is going to
the shorter distance? Absolutely, what Deepak said. So the shorter the distance, now shorter distance, let's say for instance, now between 6.7 and 6.9, the shorter distance is 6.7. Therefore, we assign it cluster 1. Okay, 6.8, 6.6. So 6.6 is shorter, so assign 2. 0 and 2.6, 1. 0.9, 2.1, 1. 3.2, 2.6, 2. 2.6, 0, 2. Is that okay? Basically, what I've done is, if the distance between the centroid point of cluster 1 compared the distance between the centroid point of cluster 1 and cluster 2, and if the distance is smaller, then it is assigned to that particular cluster. Okay.
Smaller by how much, sir?
But by whatever amount. So if you are closer to that, yeah, what, it doesn't matter. The only thing we're using is it bigger or smaller? So if it's closer to this, it is in this. If it is closer to that, it is in that. Okay. So we can of course automate this clustering method. The simple rule is, if this value is less than this value, then of course you are in cluster 1. Okay, let me, you are in 1, else you are in 2. Let me see if we'll take that. Okay, yeah. And I just have to drag it down. Okay, so I've used the if function. So if this value is smaller than this value, it's in 1. If this value is, of course, if this value is smaller, it's in 2. So basically this. Now we have the first iteration and we have assigned it into clusters. Okay, let's do one thing. Let us record this. We want okay, so we want this. This is our first iteration. Control C, and I'm copying it here. Control Alt V, and I just want the values, and I say okay. Okay, this is my first iteration.
So can we change the center point or the seed value for the second iteration?
We will now go ahead and change it. Okay, so it's an iterative process. So after our first iteration, we have classified our companies into 2 clusters, cluster 1 and cluster 2. Now we have to change the center point. So what do? So our center, our cluster 1 has this value and these 2 values, which means basically your company 1 and company 3, 4 are in cluster 1, others are in cluster 2. Okay, now let's go ahead and update the centroid. Okay, now the centroid is now going to be the average of these 3, our first cluster, which is average of this value, and this value. I can drag this formula to the right, and basically it picks up these 3 values. Okay, which is marked in yellow, that is cluster 1. Similarly, I am going to readjust the second centroid, which is average of company 2, company 5, and company 6. Okay, and I drag it across. Okay, so you notice I just did this and everything here has also got updated because I use cell referencing here. You notice that the center has shifted. You would also notice that your cluster has got realigned. So earlier what was cluster 1 is continues to be in cluster 1, but whatever was in cluster 2 earlier has now, now it is in cluster 1. I hope you can see this shift. Okay, now clusters have got realigned. Now 1 and 2 is in cluster 1 now. 2, 3 and 2, 3, 4, 5, they are all in cluster 2. I hope it is making sense. There's general silence. I'm not sure if others are catching. Are you getting it?
Yes, sir.
Yes.
Let me randomly pull someone. Yes, Shivam?
Yes, sir.
Okay,
Yes, sir.
fine.
I get
Aditya,
it.
awfully silent today. You comfortable?
Yes, sir, I'm following it.
Fine. Okay, fine. Let's move on then. Fine. So now the clusters have shifted. So which means this is a second iteration. Ideally, okay, this should be 1, 1, and this should be 2, 2, 2, 2, 2, 2. Okay, so this is our new cluster. Let us copy this. Control C, and I'm going to paste it here. Control V, and I want values to be pasted. Okay, and this is Control C, iteration 1, Control V, this is iteration 2. Now there is a shift. You would have noticed there is a change of clusters. There's a realignment of clusters. Some have gone to cluster 1 and some have come to cluster 2 and all of that. Because there is a change in the cluster formation, you have to do this exercise once again. Okay, now let us reassign these change. Let's say no fill here. Select this. no fill here. These two are now in the new cluster, and these two are the new cluster here. Okay, let's change the centroid now. So centroid 1 would actually be now is equal to average of this and this, close the bracket, drag the formula across and verify it's correct. These two values, fine. Now center 2 would actually be average of these, and let's close it, and let me drag it to the right. Okay, it's got reassigned. Okay, 6.35, 0.1, this and this and this. Okay, now you would notice our this values have got updated by itself. Okay, randomly checking. Okay, 5. Okay, this time you would notice that the cluster allocation hasn't changed. Okay, so earlier cluster and the current cluster are the same. So now, because there is no change in this, I can copy this, Control C, Control V, and paste values, iteration 3. Now, because there is no change in cluster allocation between iteration 2 and iteration 3, this actually ends up as the final cluster of our analysis. So essentially, we have to identify two clusters. Cluster 1 would comprise company 1 and company 2. Control C, Control V, and cluster 2 would comprise company 3 to 6. Control C, Control V. So there you go. You have your two clusters based on repetitive, iterative, distance between, finding the smallest distance between that. Is it okay, or is it confusing? Is it simple? Particularly, I'll come back to Amitabh. Is it okay? This is exactly what I was trying to explain with PPT.
It is okay, but how do I determine the K values? Because in this case, we took two center points.
Because you want two centroids, you want two clusters. So this is 2. K value is 2 here because you're interested in having two clusters.
If I increase the number of cluster numbers, then there will be different results.
Absolutely. You can choose to have 3 clusters, 4 clusters, whatever. Now, because it's a really small number, you have only six companies here. It doesn't make sense to have 4 clusters, right? So this is just a simple illustration of what clustering method is. I hope you've understood this. I'll go back to the slide so that you get a sense of what it is. I suppose you don't have to even go back to the slide. You understood what it is, right? What is clustering method? Okay. Arbitrarily assign 2 center points, calculate the distance from all these values to those centers, and then keep iterating that and keep changing the center until such time you find that there is no further change. All right.